Multi-stage build. Now, first and most important thing, you will need to have Docker version 7.05 or higher, and that too on the daemon and client if you want to have support for Docker multi-stage build feature. So of course, you first verify the version of the Docker on your machine using Docker version. And yes, mine is greater than 17.05. So good enough. Now what is this multi-stage build? See, in many practical situations, we would like to build an image, and the output of first image I would probably need in the second image. For example, let us say we have got one image created using .NET Core SDK. But once I have completed testing and everything using .NET Core SDK, I wanted to have a build version there with the ability to do debugging and everything. I want to now move the final thing into production. So what is published in .NET SDK, we will have to first copy that into the host, and from host we will have to move that into the new image which we want to create with .NET runtime. Basically, we want output of one image to be used as input in another image. I repeat, a simple feature is required where we want the output of one image to be used as input in another image. And this is going to be a tedious process if we have to do it manually. So this is where the Docker started supporting multi-stage build. So you can build .NET Core app in an SDK image and then copy the published app into the runtime image. So we are going to use .NET Core .NET Core SDK for publishing. So here you see now the commands build, SDK build has been used, and the build has been given some name because we want to refer to that build later. And then we have got working directory, we have got copy the project and then run .NET restore, then copy everything and then out. Now what is the advantage of having this step extra? We did not have this step extra earlier here. You see, I have restore, and before that only we are copying everything. But now let me do this. I would like to execute Docker build and say -t some image, demo image and dot. You'll see now all the steps are going to be performed in order. And at some places you are going to get using cache. And the major time is .NET restore. Major time will be taken over here. It's trying to restore the NuGet packages in the new image which is created. All the NuGet packages it will try to restore. And then the next step and so on. What I want to show you is next time if I do not make any changes to my project, I do not make any changes to the source code, and I simply execute the same command, all of them will just execute from cache and it will be very fast. See, all completed. And now I'm executing the same build command and in no time it completes all of them. Finish. Because all of them have come from cache. Now go and make the changes to the file. Hello world. Again, let us say. Now what did we do? We have modified the source code in our project. That means this command will change with this command will have to execute. Now because this command executes, All subsequent steps will not be executed from cache, including .NET Restore. .NET Restore will be re-executed and it is not needed because the original image already has the restore. So why not use the cached image which was created earlier? That is the reason what I would suggest is first copy the proj file star.cs proj into the current working directory and then perform the restore option and then copy rest of the files and rebuild it. So if any file is not modified here, it will not do a rebuild also, because intermediate stages new images are created for every stage. So that image will be automatically used in subsequent step. I have explained to you earlier how for each step a new image is getting created. So till here now we are going to have an image which will be reused every time, and only if the source code is modified the content will be copied and republished. Otherwise, even this would not republish. Same cached content would be used every time. So let's try the same command now once again. See, though I have modified actually my source program file has been modified, but .NET Restore is coming from cache. Publish was executed. It will be faster. Your build becomes faster. That is the advantage. That's it. So that is the basic reason why we should always split CS proj restore and not club it with the rest of the files build. Now, here I have multi-stage build. Let me copy this. I would like to use this now. Actually, this is the topic. I'll paste the whole thing here. Of course, this file name should change. Docker file demo.dll, that's the project name. Always remember, when you're copying, ensure that you change the Docker file. I'm removing all the comments because I want to do mapping. And you see there are two stages. Exact line numbers. No comments. So this is one stage. And again from has started, and that is considered to be the second stage. In both the cases, we have given the base image. In the stage 1, we have got base image which is SDK. And here it is a runtime base image. And these base images are given some name also here. Why? Because this name can be used in second stage. Like in this particular case, I am saying in second stage, copy the content from the build env. That means this image which is created here, final output of this is this image. From that image, copy what? Copy the content from the working directory output folder /app/out into the new image working folder, which is /app. So from old image, we are copying the content into new image, and that is what is executed. Now, again, let us run the same command. The docker build command doesn't change. The whole thing is going to be built for us. 1, 2, 3, 4, 5, and this time 10, because we have 10 commands in all. And that's it. Publish has happened. And the copy from previous build was done. And we got the final output. The result will not change. Just that two stages have been put into one. That is the basic advantage. And also remember, if needed, you can always stop at a particular build. How to stop at a particular build? Give here -- target the build name. So I have now two images. One, I can use it for development, and the other I can use it for production. Development image I will give it for the testing purpose because it will have the complete build version with source code and everything. Errors will be properly reported, whereas in production I can have a smaller sized image, that is the runtime. So yes, we can target a build. Very important. A few scenarios where this might be very powerful. Debugging a build stage. Using the build stage with the debugging symbols or tools enabled, and then lean to the production stage. Yes, the build stage we would like to have a lot of stuff which is required for debugging, including the debugging symbol files, the PDB file actually, and so on. Using the testing stage in which app gets populated with test data. A lot of test data would be required for app, but I don't want that in the production, and that's why the production build should be separated from the debug build. So here I have used from the image name, which is actually this, but mind you, we can always use the copy from another image which is having predefined name also in the place of this. So when using multi-stage build, you're not limited to copying from stages you have created earlier in the Docker file. You can use copy from instruction to copy from separate image altogether, either using the local image name or a tag available locally or on a Docker registry or a tag ID. Any of these things you can give there. The Docker client pulls the image if necessary and copies the artifacts from that particular image. So it is very interesting and a beautiful feature, really efficient. I mean, it is going to make the developer efficient, more productive, because they don't have to do the manual job of having separate builds created manually for development and production. So here is another example just for more clarity. If you are doing an ASP.NET web application, you have to create .NET new MVC and followed by that the name of the web application. You can do a build, but here you see there are multiple stages. One is we are using a nano server as base image. We are exposing port number 80 from that particular image, on which it is going to listen to the request. We have to expose that port number, and followed by that we are using another image which we are calling it as build, in which we are copying the content from the project. We do the restoration, we copy all the other files and do a build. A build is done here. And moreover, if you want, you can do a release build or you can do a debug build, your choice. And finally, we have here rather two more steps. Publish. Another image is created where we are publishing the content into the output folder. And once it is published, we can use the published image. The published image is used. Published image is used for copying the content which was published into this particular app. So by splitting into multiple stages like this, also remember the build process is going to be very fast. So once you have this multi-stage build, you can always build it and run your application like this. So building and running steps are not different, just that instead of having everything combined as one single build, we are putting it into multiple builds so that intermediate builds or the initial builds can also be used along with the final build. The images intermediate generated can also be used. So that's all in this particular chapter. Thank you.